we will be covering question number 24 in this particular episode. Question 24 is consists of two parts, part A and part B. First, let us discuss part A. If triangle ABC and triangle PQR are similar with given sides, find PQ plus QR the dimension. Given AB equal to 6 centimeters, BC 4 centimeters, CSE 8 centimeters, and PR 6 centimeters. Now, whenever two triangles are given to be similar, we should follow the same sequence of vertices. Therefore, wherever A starts, there P should come in the corresponding triangle, and the sequence should be followed ABC and PQR, either cyclic clockwise or anti-clockwise. Whichever direction you are following, that has to be maintained for both the triangles because they are similar. Now we can see that AC and PR are the corresponding sides. So the scale factor between ABC and the PQR is less than 1. It is 3 by 4 actually, because it is 6 centimeters divided by 8 centimeters, which is 3 by 4. Okay, so that let us see what is scale factor and everything. Here is the scale factor. K equal to AC by PR equal to 4 by 3. Yeah, if you take from PQR to ABC, the scale factor is more than 1. If you are trying to mark the sides of PQR with respect to ABC, then the scale factor will become 3 by 4. Okay. Now, we should find the ratio AC by PR equal to 4 by 3. This is our constant ratio, as scale factor what we call, which is 4 by 3. Use proportionality to find PQ. Since AB by PQ, AC by PR, we can write 6 by PQ equal to 4 by 3. Cross multiplying we get 4 into PQ is 18. Therefore, PQ is 4.5 centimeters. Now find QR using the same ratio. Since BC by QR equal to AC by PR, half 4 by QR equal to 4 by 3, cross multiplying 4 into QR equal to 4 into 3, QR equal to 12 by 4 equal to 3 centimeters. Now we are asked to find the sum of it PQ plus QR, which comes to 7.5 centimeters. Part B. Given conditions, proportionality QR by QS equal to QT by PR, equal angles are 1, 2, these two angles are equal. Fine. In that case, what we are asked to find is, or to prove, triangle PQS and triangle TQR are similar. This is what is to be proved. Okay, diagram is next to us. We can see that from P lies, point P lies on segment QT. Yes, point P lies on segment QT. Point S lies on segment QR. Okay. Similarity criteria or proof. To prove that triangle PQS is similar to triangle TQR, we'll use the SCSI, side angle side similarity criteria. SAS similarity criteria. This is one of the most powerful tools in providing triangle similarity. Now, two sides must be proportional. We need to show that the ratio of corresponding sides is equal, that is QP by QT and QS by QR. The included angle must be equal. The angle between these two sides in both triangles must be the same, that's triangle PQS equal to triangle TQR. It's a similarity theorem. If two sides of one triangle are proportional to two sides of another triangle and the included angles are equal, then the triangles are similar. Fine. This is one of the most powerful tools in proving triangle similarity. Two sides must be proportional and the included angle must be equal. Right. So here we start with proving our similarity condition. First step is rewrite the given program, given condition. Given QR by QS equal to QT by PR, and this is our starting point from the problem statement. And say step 2 is rearrange algebraically, taking reciprocals on both sides. QS by QR equal to PR by QT. Okay. This helps to identify the proportional sides. Third step, express in the ratio. Since P lies on Qt, we have Qt equal to Qp plus Pt. From the proportion Qp by Qt equal to Qs by Qr, this gives us the required ratio. Okay, what is part B? So part 1 is completed with all the conditions satisfied, and we move on to part B. Identify the common angle. Okay, there is a common angle is given. Identify the common angle. PQS and TQR. These two angles are equal. PQS and TQR. Yes, these two angles are equal. Now, because it's a same angle, right? Included angle, common angle. Yeah, that's why they are equal. Now, both angles are at vertex Q and R actually the same angle. This is the included angle between the proportional sides QP equal to QS and QT and QR respectively. QP QS and QT QR respectively. Step 5. Apply SA similarity. We have established QP by QT equal to QS by QR, and PQS is equal to TQR, included angle, by the SAS similarity criteria. Triangle PQS equal to triangle TQR, and hence proved. Right. Okay. Thank you.